We are asked to graph this equation, y equals 2 times the quantity x plus 2 squared minus 4. You're also going to be given the domain and range. Now, in order to graph this well, you have to recognize right away that this is a quadratic. And I know it's a quadratic because I'm going to end up with an x squared term, right? X plus 2 is in a binomial that's being squared. So that immediately tells me I'm going to have a parabola, right? It's going to be a U-shaped graph. The other thing I have to recognize is the form that it's in. There's three forms that we have studied with quadratics: standard, intercept, and vertex. Now this is in vertex form. So it's important that you recognize that, and you know that this is y equals a times x minus h quantity squared plus k. And that hk is your vertex. Whatever value is here, combined with whatever value is there, that's going to make you a vertex. That's going to be this part of your parabola. So my vertex, I can tell by looking. Now this is kind of tricky because it's supposed to be subtraction, but I see addition. That means it's a minus minus 2. So my vertex is actually negative 2, and then this is very clearly a minus 4. It's supposed to be positive, so if it's a negative, that means the number itself is negative. My vertex at negative 2, negative 4. Now, the other thing I need to know from vertex form, or I get to know from vertex form, is this a value. That a value is going to give me my stretch, my shrink, or my reflection. It's basically how it's growing from the vertex. So my a value is 2, which means this is going to be oriented up, and there is going to be a bit of a stretch by a factor of 2. It's growing twice as tall as the parent function. All right, so I'm going to graph this, and it's going to be negative 2, negative 4. So I'm going to set up my coordinate grid to make sure I can accurately graph that vertex. All right, x and y axis. This is x, this is y. 1, 2, 3, 4, 5. So that's negative 5. 2, 3, 4, 5. Same thing. Okay. Now, technically, I don't need a table from here, but we talked a lot about using a table. So let me get the vertex going, and then I'll show you how to graph with or without it. The vertex is at negative 2, 4. So at negative 2, 1, 2, 3, 4. That's where my vertex is. Now, it is growing up from there. Now, typically, here I'll do it the parent function over here. The parent function, y equals x squared, is this function right here, where it is centered at the origin, and then the growth is with perfect squares. So it's 1, 1, because 1 squared is 1. Then it's up 2, 4, and it's symmetrical on either side. And my next point would be at 3, 9. But I'm growing with my perfect squares. And from the vertex to the right 1, up 1 is important. To the right 2, up 4 is also important, right? So this is 1, 1. And this is 2, 4. Well, if I know my a value is 2, then I know I'm going to grow with a stretch from that parent function. So I'm going to go 1 to the right, and instead of going up 1, I'm going to go up twice as high. I'm going to go 2 to the right, and instead of going up 4, I'm actually going to go up 8. So that's going to actually be pretty high here. It's going to be all the way up. It's a y-intercept right here. And then the same thing is happening over here on the left. So I go over 2, and I'm up here to 4. So this is the point 0, 4. This is the point negative 1, negative 2. And I just got that from the stretch. I knew how it was growing, so I was able to connect it. And I get a nice little U shape. It's going up that way. Now, you can also just use a table, and we've talked about this a lot in class, where if we're struggling with getting the quadratic growth by growing with our perfect squares, we can just set up an XY chart, right? But what's really important is the vertex has to go in the middle. I'm going to have negative 2, negative 4 here in the center of my graph. And then from there, I'm going to build points around the vertex. So my x inputs are going to go here, maybe negative 3, negative 4, and then negative 1 and 0. And these will be the values that I'm going to input into my function in order to find corresponding y values to plot. So if I go to my equation, I'm going to input negative 1 and 0. So I'll do 2 times, okay, x is negative 1. And we're going to do plus 2. And we're going to close those parentheses. And we're going to square it. And we're going to subtract 4. And that's negative 2, right? And that's what I was anticipating, right? I have the point negative 1, negative 2. If I do that same thing, but I'm going to input 0, so I'll just bring that thing back up, and I'll change that negative 1 to a 0, and I'm going to get 4, which again is what I anticipated from my quadratic growth. I can get the rest here. Make that a negative 3 now. Right, I'm inputting a negative 3 for x. I'm going to get negative 2, and that corresponds to this point right here, which I already had graphed. And then I can do it again, make this a negative 4. And I'm right up here at, what is this, negative 4? 4, that's that point right there. So either way will work, whether or not you use the table or you just get quadratic growth. You're going to get the same graph from vertex form. So really important that we recognize that this is in vertex form. We know what vertex form looks like, and we know how to apply it. Now, it did also ask for the domain and the range, so we can put that on here. Our domain is our potential x values. Well, this thing is going to grow forever left to the right. There's no restriction on any kind of input I can put here in the function. So x is all real numbers, and that's the notation for all real numbers. X is in the set of the real numbers. The range, now this one does have a restriction. We do not have infinite outputs. If you look at the graph in terms of the y-axis, we do not grow forever up and down. We are actually have a low point, right? The lowest value that we'll see on y is here at the vertex at negative 2, negative 4. So this value here represents our lowest y value. It only grows from there. So our range is going to be everything, but as long as we're above that low value for y. So it'll be all real numbers for y, provided y stays greater than or equal to negative 4. It's going to be everything above that low point. Okay, hope that's helpful. A little review for graphing quadratics. Message me anytime with questions.